Welcome to the 16th Quarterly Report, detailing the progress made by the ARES Projects Office on America's launch vehicle technology. Last quarter, ARES reported on post-test inspection of the first stage development motor, upper stage test articles, and J2X materials testing. This quarter, work continued on upper stage manufacturing facilities, J2X component fabrication, and first stage avionics. First stage engineers conducted the third drop test of the Drove parachute system on April 14th. The 77,000-pound payload was the largest load ever dropped from a C-17 during flight. The drop test successfully met all its objectives and provides ARES with important data for designing the first stage recovery system. Avionics systems for the first stage were manufactured this quarter. Testing was performed on individual circuit boards as well as integrated avionics boxes. After testing was completed, the boxes were shipped for integration at ATK's Engineering Development Lab. The new first stage motor will use 4 separate strings of electronics to manage thrust vector control for the vehicle. ATK is using a full-scale mock-up of the first stage forward structures to install and test the avionics subsystems. This also helps simulate and refine the placement of those boxes in the vehicle. The testing this quarter began with power-up and switching, initialization testing, command execution, and data recording while executing a mission simulation. ATK is also preparing for the second full-scale static test firing of a 5-segment motor this September. Development Motor 2 has been cast and is being installed at Test Stand T97, where the first development motor test was conducted last year. When test fired this fall, DM2 will demonstrate design refinements and processes and test performance of the motor under lower temperature conditions. In addition to the upcoming full-scale tests, Marshall engineers conducted a test firing of a subscale solid rocket motor in May. This subscale testing provides a quick turnaround and low-cost method for examining new materials and designs. The test motor's nozzle was a scaled-down version of the design used for ARES 1 development motors. The test data will give engineers a better understanding of the design's performance and materials. In another first for ARES design and manufacturing, Lattice Company completed the forging of the first stage forward skirt this quarter. By forging the skirt as a single piece, rather than welding pieces together as is done on current hardware, the forward skirt is stronger and more lightweight. Ring rolling and pressing techniques are used to shape the final piece while maintaining a consistent material grain structure in the part. Full-scale manufacturing will be performed at Michoud Assembly Facility, which took delivery of additional tooling this quarter. The X and Y columns for the robotic welding system were delivered and installed, moving the facility at Michoud closer to operational capabilities. The J2X engine will use a regeneratively cooled nozzle consisting of more than 500 metal tubes banded together. This nozzle must withstand temperatures of over 2,000 degrees Fahrenheit. To accomplish cooling the nozzle, cryogenic liquid hydrogen will flow through these metal tubes and then back into the main combustion chamber to be burned. The nozzle assembled here will be part of engine 10001, the first development test engine for the J2X effort, scheduled for completion by December 24th this year. The Heritage Fuel airflow turbine test at Marshall employed a new technique to physically test Heritage J2 engine hardware under the more demanding conditions required by the J2X. This test series is intended to verify computer simulations before advancing to more expensive and time-intensive engine hot fire tests. This new technique used the most heavily instrumented turbine test rig NASA has ever employed. Manufacturing of subsystem components for the J2X engine is well underway. At Major Tool, the turbine exhaust manifold and main injector components were machined this quarter. At Metalex, valve housings that regulate propellant flow and the nozzle manifold that captures hydrogen coolant and redirects it for combustion are being manufactured. These and numerous other high-tech small businesses around the country are hard at work creating the thousands of pieces of hardware needed for the J2X engine. Join us next quarter for news of progress made by the ARES projects, including Development Motor 2, upper stage manufacturing tests, and J2X engine fabrication. For more information about ARES development and progress, visit us on the web at nasa.gov/ARES.